right, so we're going to move on to the third lesson of our probability chapter, and that one is called counting outcomes. So we've done this last year, and we're just going to kind of add some stuff to it this year. So a tree diagram is one way to do that. It's a visual display to find the number of outcomes given a number of choices. Another method that relates the number of outcomes to the number of choices is the fundamental counting principle, which is actually a definition down here. I'll rephrase that so it makes maybe a little more sense here. The fundamental counting principle multiplies each event's possible outcomes together. So in example 1, we're going to draw a tree diagram here. It says how many different combinations of beverage and bread can be made from 3 beverage choices and 3 bread choices. Draw a tree diagram to find it. So we have, I'm going to call it, I'm just going to make some names. So we've got wheat for our bread, we've got white and rye bread. So then, after we pick a wheat bread, we still have a choice of water, lemonade, or pop. Those would be our 3 beverages. Same with white, I could pick water, lemonade, or pop. Well, if I picked rye, I still have those 3 choices of water, lemonade, or pop. So if we were to count all of these final outcomes, we have 9 outcomes, which the fundamental counting principle just says, here's event 1, which is the wheat, there's 3 of them. Event 2 is 3 beverages, 3 times 3 is 9. So this is the visual way to do it. Here is a little bit shorter as long as you understand the fundamental counting principle. So now it says, refer to example 1, use that fundamental counting principle to find the total number of outcomes. So a couple of examples here. For each situation, draw a tree diagram to find the number of outcomes. So a closet has a red top, a blue top, and a white top. So our first event is shirts. Our second event is bottoms. So we could pick a red, a blue, or a white. And then after we pick our shirt, we could pick pants or skirt. What if we picked a blue shirt? Pants or skirt, still our options. A white shirt, pants or skirt. Story of my teaching life. So then if we count all of these outcomes, we have 6 outcomes. Which makes sense because this is 3, this is 2, 3 times 2 is 6. 3 pennies are flipped. This one gets a little tricky, so try to give yourself some space here. So, or if you think of 3 coins, so the first option for a penny, what could you flip? Well, you could flip heads, or you could flip tails. Let's say you flip another penny. This is our first penny. Our second penny, the options, if after we flip this one, would be heads or tails. If I flip tails the first time, I still only have heads or tails. The third coin, or the third penny, your options after getting heads or tails is still heads or tails. If we flipped heads, tails, we still only have heads or tails. The only option we ever have are heads or tails. This is 2 options, this is 2 options, and this is 2 options. 2 times 2 times 2 is 8. If you count here, 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes. So you could have one that's all heads, one that's all tails, and then we have a series of in-betweens. You have to follow your branching tree if we were finding probability, which we're going to do on this side. So this one says use the fundamental counting principle to find the total number of outcomes in each situation. One six-sided number cube is rolled, so we've got 6 possible events there, or 6 possible outcomes. 1 card is drawn from a 52 deck. So 6 times 52. Because we have 6 options for the dice, 52 options for the cards, so we get 312 outcomes. One letter, so if we're talking about the English alphabet, there are 26 letters, and 1 digit from 0 to 9. Careful here, 1 to 9 would be 9, including 0 is 10 digits. So if we multiply by 10, we get 260 outcomes. Now we're going to move on to something that says find the probability of event. So remember that probabilities are fractions, decimals, and then the percent you can get from those. When you know the number of outcomes, you can find the probability that event will occur. So an ice cream parlor has a special where you can build your own sundae for $3. You're given a choice of chocolate, vanilla, or strawberry. Okay, so we've got three flavors. Sprinkles or nuts. Okay, so we've got 2 toppings. And chocolate, and 2 drizzles. So what is the probability of randomly selecting vanilla ice cream? So how many vanillas are there? There's 1 out of how many flavors? 3. Times, that's what the fundamental accounting principle says. Let's see, vanilla ice cream. Nuts, that's 1 option out of 2 for the toppings. And we're content with caramel or chocolate. So that's 2 out of the 2 that they gave us. To multiply fractions, you multiply all the way across. But you could simplify this first. 2 divided by 2 is just a solid 1. So really we're just looking with 1 times 1 times 1 over 3 times 2 times 1. So you have a probability of 1/6, which you could then convert to a decimal. I'm going to round and then to a percent. Rounding to the nearest 10th or 100th, depending on how you think about it. Okay, so a couple more where we're just going to practice here. A dresser has 4 shirts and 3 pants. If each shirt and pants is a different color, what is the probability of randomly selecting a blue shirt? It's important that they're different colors so that you have a fair chance of getting all of them. So blue shirt, that would be a 1 out of 4. Black pants, 1 out of 3, would be 1 out of 12. And then you could convert to a fraction decimal percent. There's 6 cell phones and 23 covers. If each cell phone is made by a different company and each cover is different, what is the probability of randomly selecting a telecom phone? So that's 1 telecom out of 6 cell phones and 1 green cover out of 23 covers. So we have a 1 or 6 times 23, 1 out of 138. It's going to be a very small chance, but I've seen smaller, like the odds of winning or the probability of winning the lottery or getting a 29-hand in cribbage. A computer store offers 11 computers, 23 keyboards. If each computer and keyboard are made of different companies, what is the probability of running a Computes computer? So 1 out of 11 times a Language Inc. keyboard, 1 out of 23. 11 times 23. See this? These odds are even smaller. A nickel and a dime are flipped. What is the probability of getting tails, then heads? So on a nickel, if we want tails, that's 1 out of 2 options. And then a dime, we want heads, that's 1 out of 2 options. So you have a 1 and 4, which we hopefully know this one as 0.25 and 25%. 3 different ways of writing probability. Fundamental accounting principle and finding the probabilities. Have a great day.